All right, so we're going to be looking at some phase diagrams today. And what phase diagrams do is they just show you the relationships between the three most common states of matter. And so we have our solids, our liquids, and our gas. And then we also have, if we look over here, we have our supercritical fluid, where you're kind of like outside of the normal realm. So we've been talking about the states of matter, and we talked about what a solid is, what a liquid is, what a gas is. We have also talked about, how we phase change them. So there's two really interesting points that are typically on the this. The first one is right here at the triple point. Oops, sorry, I'm gonna do that. So what we have here is we have a point where all three phases can exist simultaneously. So you can have a solid, you can have a liquid, and you can have a gas. And they're all going to actually exist at the same time, which is a pretty interesting thing. And if you look at the graph, you can see it right here. That's our triple point. The critical point is basically where you can no longer just be a liquid. So if you're looking on your graph, it's going to be right over here at the kind of where the little C is. That's your critical point. You can see once you go beyond that, then you're in this thing called supercritical fluid. And it's basically like you don't follow the rules of a liquid anymore. So your two most interesting points on a phase diagram are the triple and your critical. And we'll look at a couple different ones. So this is just taking a nice simplified version of it. So your solid's always going to be on the left. Your liquid's always going to be on the upper right. And then the gas is always on the bottom. And if you look here, your axes are always pressure, and then also your x-axis is your temperature. So you can see as we increase pressure, we typically become a solid, or if we're out further, we become a liquid. Because if you put gases under too much pressure, they solidify or liquefy. Remember, in this case, B would represent our triple point. And over here, C would be our critical point, where we can no longer be a liquid. And then this just kind of explains what you saw there. So it says line A to B. So we're talking right here. Line A to B is that border between the solid and gas. Line B to C is just our liquid gas. Line B to D is our solid to liquid. And one thing you'll notice, you may want to note on B to D here, it says for this guy, it usually slopes slightly to the right because the pressure increases. And that's because most solids are denser than liquid. An important difference in this would be water. This is really hard to write with. Water is, we know, slightly different, so we know that ice is less dense than water. So the water actually slopes to the left as opposed. And then we said before, we know there's a critical point, and we also know there's a triple point. For water, this is our critical point right here. So you'd have to be 374 degrees Celsius and 218 atmospheres, so it's pretty intense with that. And then this is just a thing showing you two different things. On the left, you have the water one, and you can see that the slope is different than the other ones. And it's, again, sloping to the left because ice is less dense than water. Whereas on the right here, this is CO2, and you can see that the slope is to the right. And that's because this is more typical that the CO2 solid is more dense than the CO2 liquid. So really all they would expect you to be able to do is to be able to read these, like know that it goes solid, liquid, gas, know what a triple point is, know what your critical point is, and go from there for this.